Hey guys, this is your week 5 quiz, and I decided to go over this because I saw a lot of you struggle with the first question. Second question, there were some mistakes, but for the most part, it was an okay performance. But this question, so many of you were really lost, so I thought I would go over this. So the question starts with this. The agency will select a random sample of 500 voters. So that's an information I need. N is 500. And it seems like they did SRS. Region A of the city assume that the population proportion, so P, because it's a population proportion, is 0.47. So that makes Q 0.53. I don't know if I need it yet, but I will just write that down first. All right, part A. What is the probability that the proportion of voters in the sample of region A who support the ballot measure is greater than 0.50? So there are two approaches you can take. So first, I'm going to show you is the normal approximation approach, and then the second one is a binomial. So let's look at this. This is a binomial setup, right? Because it seems like things are independent and there are only two choices and so forth. So when that is the case, if it meets two conditions, it could be we could use normal distribution. So the conditions I need to meet is a large enough condition. So we have to state is the large enough condition satisfied. And that was NP is greater than equal to 10, I think. And then NQ also has to be like that. So I guess we did need, so we are going to do this. And then 500 times 0.53 is greater than 10. And they happen to be all both greater than 10. And this is a random sample. So, and we can assume that this is simple. The sample is random. And it's safe to assume that 500 voter is less than 10% of the population. So I'm abbreviating here so I don't take up too much time writing. But so that's the condition. Therefore, you need to indicate. Therefore, we can assume normal distribution. What is the mean? So mean of 0.47, right? And then the sigma, so I put the equation here. So this is from your College Board formula sheet, okay? And this is something that I would keep it as notes. Like I will keep notes of all the conditions that you will ever need for every inference test in case it shows up, yeah? And so I'm gonna do that. 0.47 times 0.53 over n, 500. So this is my distribution. And I'm going to draw my distribution just to be on the safe side. I know that the mean is this. It's asking greater than 0.50. So this is what I'm interested in. Okay, the area under that. So obviously, we could use normal CDF. But when you do normal CDF, just be careful because you will have to state everything that you're doing. So I'm just going to write it as, I want to erase. And then write it as Z is greater than whatever this is. Because remember, 0. And then I guess the standard deviation is about this. And then after you write this, you can just plug it in a calculator and it gives you 0.089. So this area is 0.089. So the probability is 8.9%. Obviously, you need to show all this work to get it essentially correct. Most common mistake I saw was this, sigma. You didn't know which sigma to use, even if you use normal approximation. Or you didn't provide enough evidence to say why we could use normal distribution. So you lacked the condition checking. So make sure if you're don't start assuming that they know what you want to say. If you're using normal, then tell them the reason you can use normal distribution is because it meets this condition. So obviously this notes would be very helpful if you have it all organized. All right, so I told you there's another approach, which is a binomial approach. So because this was a binomial setup, we could just use a binom CDF, okay? So we say, since there are only two outcomes, and it seems to be that x, the random variable x, is we need to define what x is first, right? X is the number of voters out of 500. Seems to be random and independent. We use binomial distribution. So again, you're going to explain shortly why you are using certain distribution, okay? Unless they say that use binomial distribution, and you have to give a reason why you're doing that. So binomial distribution notation was that, and it was n comma p. So again, it would be nice to actually write everything. Q is 0.53. All right. And because it's asking for 0.50, the number that we are trying to get is 250, right? So 250 is 500 times 0.5, and that's my goal. And so we want probability of x greater than 250, because it said greater than 0.5. Then I can do 1 minus binom CDF. Oh no, before I write that, I will write p, x is less than or equal to 250. And this can be found by using binom CDF, right? And then if you do that, you get 0.0825. Okay, so this one is definitely less writing because you don't have to check the condition. But then you need to be able to recognize, is this a binomial setting? And if you can do that, this is not that difficult. Okay, this one, part B is, there's a little added part to it, right? So they got region B, they got another random sample, but now 400 voters. So let me get the, I'll write a notation and a B as 400. And B is straightforward enough that you don't have to define everything. It says the P of B is 0.51. That means Q of B would be 0.49. So it says describe the sampling distribution of difference in sample proportion. So it's not really asking you to test for anything, but when you describe the sampling distribution, you need to tell the shape, the spread, and the center, right? So center and spread, you can describe it with number, because if you find the mean and if you find the sigma, then you're good. Shape, you will have to determine. And since we already know that we could use normal approximation from A, right? But if you didn't prove that in part A, well, you have to reprove it here. So I'm going to write NA is 500 and P of A was 0.49. and Q of A, is 0.51. And it's asking region B minus A. So it's looking for distribution of PB minus PA. And then it's looking for sigma B minus A. That's what it's looking for, right? So let's do this. We need to determine whether they're both large enough to use a normal approximation. So we're gonna test NA times PA is greater than 10, and A times QA is greater than or equal to 10, and you do need to plug in the numbers, right? Sorry, my writing is not very great. So since it satisfies they are both NP and NQ are both greater than 10, it satisfies a large enough condition, we can assume normal, and then you can say the same for this. So I'm going to just do very quickly. So you'll be writing this out. I don't want to run out of time, that's why. Both satisfy, so normal. So since you're doing this distribution minus this distribution, since normal minus normal will be still normal, so we know this would be a normal distribution. With, you do 0.51 minus 0.49, or is it 47? 47, sorry. Which is 0.04 as your new mean, and then your sigma would be using this formula. And again, this is in your formula sheet, okay? So know how to use your formula sheet and plug it in. Plug all the numbers in, 7, and then you'll be fine, okay? You'll be fine. And I guess, you have to switch this too because my P1 is actually PB. And then you get 0.0335-ish. So this is a distribution. It's a normal distribution with mean of 0.04 and sigma of 0.0335. Okay, so this question was the last question of this section. This problem number 1. It says what is the probability that it will differ more than 0.05? So you need to understand that differing from more than 0.05 can be this end or this end, right? So that's why you need to get a probability where PB minus PA is greater than 0.05, and then you have to add that to less than negative 0.05, right? Less than negative 0.05, because what if PB is smaller than PA, right? So it's basically you're adding up the two z-score. So basically this transfers to this. You can rewrite this, and 0.04 and 0.335 comes from part B. So I guess if you did part B wrong, this would have been wrong as well. Obviously, because we established conditions in the part B, you don't have to re-establish, but and then this is mostly just a z-score problem, and so this formula you don't need it. So I hope this kind of clarifies some of the things maybe you're confused about. I guess I don't know where the confusion came from, or if the question itself was just like presented in a way that it was very difficult. I think if you remembered how to use a normal approximation for the binomial distribution and had a formula sheet next to you, this would have been very doable. And so I would strongly suggest that you have your notes and formula sheets next to you when you take these quizzes, because that's what you're going to do for the actual exam. Let me know if this was helpful at all, and I will try to make a video for the quiz that you're taking today. I will see you later.